Hi, everyone. Thank you so much for joining, and we really appreciate the time. Today, we're going to be diving into Let's Learn .net and focused on semantic kernel. So we're excited to chat with you more and to go through some slides with you. And then we'll also get into some of the Learn modules as well and go through some of that and then have some time for Q&A. Before we go any further, I want to give it a chance to introduce ourselves a bit more. I'm going to turn it over first to Matthew. Matthew, you want to introduce yourself?
Sure thing. Thank you, Sophia. My name's Matthew. I'm the group product manager for Semantic Kernel, and excited to share with you how you can use Semantic Kernel to build AI applications. We built it for all of you to really easily use AI applications as .NET devs. So yeah, excited for y'all to learn more. Sophia, back to you.
Perfect. Thanks, Matthew. And so, everyone, I'm a senior product manager in the Semantic Kernel team. And like Matthew, really excited to dive in and learn from you as well and be able to dive into questions. Just a bit of our agenda that we'll be covering here today. We'll have a bit of an overview of Semantic Kernel, and then we'll be able to showcase some of the Learn content to be able to dive in further as well, and then be able to go through building out the kernel in that module and then creating plugins as well. Then we'll have some time for Q&A, any questions you may have around Learn content or what we've presented out as well. But with that, let's go ahead and dive in. So just kind of setting stage and taking a step back, when we have come into the AI space, what we've seen is that a lot of customers have had current environments where they've had lots of different applications. A lot of them have been constrained interactions that are very much limited to one app and one very simple interaction. A lot of these customers we've interacted with and learned from, they've had thousands of applications. And so within that, if you want to do any sort of change, it's very costly and very complex with all these different pieces that are going on. A lot of the times in these applications, we've seen that the data is hard-coded and it has fixed data sets. But what we've really been starting to see within the AI space is this paradigm shift, and where customers are starting to think about intelligent apps, which we'll dive into with Semantic Kernel a bit more today. But they're starting to think of what's possible, right? How can they start to have those natural language interactions? A lot of them are starting with chat-based applications with an AI, of being able to have that back and forth with a bot and be able to move even further into what we're seeing with image, video, and other mechanisms as well. A lot of these are able to be more personalized experiences that are data driven and able to improve over time. And so it's really in the all ecosystem, some of the shifts that we've been seeing as well. And so diving even further to what we've been seeing in organizations is the AI teams primarily in the past have had to focus on creating AI models. They've had to spend a lot of time in getting these all finalized, go through all the testing to make sure it has a good confidence interval before moving on to anything further. And it's primarily been in Python. A lot of the AI teams will be focused in Python. But what we've been seeing lately is with all of the changes in the last couple of years within AI models, they've gotten so advanced and so good that a lot of these AI teams no longer have to focus on creating those AI models, but can start to move into this middle section here, being able to go through and make prompts, which we'll chat about today, plugins, and other things as well, and really be able to think of what's possible with AI even more within organizations. But once they have this rolled out, they're not able to deploy that to production environments. And that's really where the app development teams come in. Those teams are very familiar with the process of creating apps, being able to go through any of that brainstorming, evolution, be able to deploy them out into production, and then really be able to maintain them as well. Primarily, those app teams have been focused in Java and .NET, and we're able to really give them then the tools between these two teams, which is where we'll chat about with Semantic Kernel, the potential there. But what we've been able to see as well is that within this evolution within AI, the app development teams and AI teams are really able to talk to each other and be able to share lessons learned of what's going on in production when these apps are deployed, and be able to feed that back to AI teams as well to be able to improve over time. And so diving into what we see being some of the essential elements of intelligent apps, a lot of the items that are really beneficial that customers come to Microsoft for and come to others is those pre-trained AI models, right? Of not having to spend the time making models, being able to really get into the weeds of other items within that. Within Microsoft, we're scalable and we have high performance as well. And so, with that, being able to handle high volumes of data, be able to go through and have that high performance is another key reason why customers are coming to Microsoft. And then being able to have that simplified app delivery. That's really where the semantic kernel pieces that we'll talk about today come in, but being able to have something that's ready to go, developers are able to very easily ship, be able to make a couple of changes for their environments, but it doesn't take a lot of time and a lot of coding for them to be able to go through. And so just a little bit of what we've been seeing in intelligent apps as well. And so diving into where semantic kernel really comes in, what we've seen in customers' environments is that they typically have apps where they're having great calls within APIs and being able to have all those key pieces within Azure as well. And a lot of them may try to make their own co-pilots, but what we've really found is it really is the easiest and really the best possible solution to go through and have this AI orchestration layer in the middle and be able to rely on that to make any of these Copilot applications. And this AI orchestration layer, that's really where semantic kernel comes in. And so diving a bit further into that orchestration level, there's a couple of key terms and things that I want to get you familiar with today that you'll be seeing a lot in the Learn content as well. So for prompts and response filtering, it's just being able to call your data, be able to give the AI that specific piece of information within there. And then getting into the next step of meta prompt, it's really being able to give your AI that description of what its job is, of what it's going to be doing, being able to have that job description as well. And then diving into the next piece, grounding. We'll go through this a bit in the module as well today, but within the AI models, they have a whole lot of knowledge, but they may not have the very specific knowledge of the scenario you're going through. What we've seen in customers' environments, they may not know about your organization structure, other nuances as well. And so grounding really gives you the opportunity to be able to give the AI model specifics and be able to ground it in things that are unique to your scenario as well. And then plugin execution is just being able to call back with your data, be able to call through a plugin to be able to go and execute your code and be able to have that as well. And so just some of the terms that you're going to be hearing today as we walk through that want to get you familiar with as well. And then the other key piece that I want to call out here with semantic kernel is the AI safety that's just baked in. So instead of having to go through and create a lot of these pieces and go through and spend the time, developers just know that responsible AI is baked in and that that's just a key principle of semantic kernel. If there are additional safety things that they're wanting to create in their copilots, they're able to add that in. But it's a really big call that I want to make sure that folks are aware as if we're diving in and learning more. And so for that, that's really where semantic kernel comes in. It is that lightweight open source orchestrator, that middleware, that layer that we were showing that really allows you to be able to take your apps and be able to add in AI very, very easily. And we'll be able to walk through just how easy that is today in the Learn module. And so it is available right now in all three coding languages of Python, .NET, and Java. And so it's really able to meet developers where they're at. We chatted earlier around the AI teams that are typically in Python. It's able to meet them where they're at. And then those app development teams that are in Java and .NET, it also has that parity. We are at 1.0, which means that you're not going to have any breaking changes as you're deploying this out in your environments or for customers as well. And so just a couple of things to note as we dive in. And so talking about a couple of our product pillars that we have and a couple of key pieces of semantic kernel. The key piece around semantic kernel of why we've made it open source is we knew that as everything was evolving very quickly with ChatGPT, we wanted to give customers the ability to really see what's going on, right? It seems like a black box at times that there's magic happening behind the scenes, and to make sure that developers and folks were able to go through and not only have the ability to see what's going on as you're making these calls to the AI model, getting that return through the kernel, but really able to customize it as well for your environment. Another key principle that I want to highlight is it's reliable, right? We know that copilots are being built on this every day externally and internally to Microsoft. And so making sure that we don't have any of those major breaking changes with it being at 1.0 is very key principle for us as well. And then another key principle for semantic kernel is it's trustworthy, right? We touched on the AI safety as well, of being able to make sure that you're able to add in safety measures, but those are just baked in. We know that that's very, very key. And then you're able to also use this within different AI models, right? We'll be walking through Azure OpenAI today, but it's very easy within the connectors. It's one line of code to be able to change for different models and different items as well. And so a couple of core concepts that you're going to hear a lot and you're going to hear in our module: plugins, planners, and personas. And so to really make this come alive, I'm going to go through an example of something that I use semantic kernel for day to day. And so I go through and have to write a lot of blog posts out for semantic kernel. And it can take a lot of time to not only do the research that you need, but be able to go through and get all the information. And so for a plugin is just a way to be able to call data and using an API to be able to get pieces of data. And so for me, I use plugins a lot to be able to go through and do research and be able to pull together information. And then kind of moving on from plugins, planners are just the ability to be able to combine multiple plugins together. And so you may have multiple data calls, you may have multiple pieces of data that you're wanting to call in your research. So being able to call multiple plugins together and have a plan is really key in being able to go through and create semantic kernel. And it's a really key fundamental differentiator of why individuals use semantic kernel, right? Instead of just making one call to an AI model, you're able to have multiple steps with that as well. And then personas, we chatted a little bit earlier around grounding and meta prompting. It's really being able to, within your AI, give it that personification and be able to make sure that it has the details that it needs about your scenario as well. And just making sure that it has the very key job description of what it's tasked with going and doing as well. So from here within plugins, diving in a bit further. So in my example, right, I have a lot of data for some of the blog posts I'm trying to go through and do research and get information on, and maybe around the number of semantic kernel calls via Azure OpenAI. And so being able to have a plugin that you're able to use to go through and interact with the kernel and then be able to get the data from your app as well is very key and crucial within plugins. And so being able to have those API calls is really the key fundamentals of plugins. For planners, it's really being able to have a request, have it go through semantic kernel, and then call multiple plugins. So I'd mentioned I may have research that I need from multiple apps. Another great example is if you're trying to go through and get information around meeting with customers, right? A lot of the times you may have to look at a dashboard, get the top 10 accounts that you've been interacting with, and be able to go through and then not only get that information of top 10 accounts, look at when's the last time you've met with those customers, when's the last time that you've interacted with them, then be able to have a call to your calendar to look at that, and then another call using a different plugin to be able to schedule appointments as needed. And so the plugins are able to then within a planner have multiple plugins that are combined together to execute the plan and then give that back to the user. And then just touching a little bit more on personas. So coming back to the example I talked through around blog posts, personas are really being able to give that job description to the AI agent. We find that within this, it really works best when you have specific agents for a specific task. We find if you have jack of all trade, right, they're not going to do very well. And so very much having an agent that has a very, very clear job description, they're very focused, has been very, very helpful as well. And so we are going to dive in with kind of the blog post example I chatted about for this with personas. I would need a project manager agent to be able to go through and understand what is the timeline for being able to get the information back for the blog post I want to be generating? What are the different mechanisms and different tasks that they'll need to complete? And so being able to have that project manager that's keeping all of that in mind as you send out your request. A research agent, as I mentioned earlier, right, going through plugins, going through all the data that I would need in creating this blog post, having a research agent that's very, very focused. And we'll get into some of the different plugins as well that a research agent could use later, but being able to have a very clear agent that's focused on that is very beneficial. And then having both copyright and designer, one for just writing the blog post, drafting it saves me so much time instead of having to go through, draft all this content, to have an outline, be able to go through, fine tune, and then design as well for the designer agent for any sort of graphs, images, or anything to create. And so from those personas, right, there are so many different agents. You really need to be able to manage all of the different agents, be able to interact with them in the right way. And that's really where the agent orchestrator plugin comes in. So being able to have an orchestrator that will call these different agents at the right time and be able to go through and execute that flow. And so coming back to that blog post example, right, if I had made the request of help me draft a blog post, you would be able to then engage with that agent orchestrator plugin that would be able to then interact and bring in that project manager agent. And that agent would be able to understand really the scope, understand the timeline and the pieces to call. And that project manager agent would be able to go first and call that researcher agent, go through, do any research that you would need, right? For me, be able to get data from multiple apps, be able to do any sort of summarization or any information that I would need, and then be able to return that back to the project manager agent, who will be able to get that information and proceed and relay that to the copyright agent. That copyright agent would then take all the research, all of those pieces, and take from my request of the specific topic for the blog post and start to draft and write it out and be able to use that information to then finalize and have a drafted post, and then give that back to the project manager agent, saying, hey, I'm done, go ahead and proceed for next steps. Then that project manager agent could go through for design. You may have images or other things to be able to create or pull in and be able to have that generated from the work of the prior agents. Then relay that back to that project manager agent and give it back to the user. And so having that orchestrator really allows you to call agents when you need them in the right time and be able to really orchestrate that together. And so a couple of focus areas as well of semantic kernel I want to touch on, right? I talked about a little bit earlier, but I just want to make sure and emphasize that all of our kernels and packages are at 1.0 and beyond. And so you're not going to have any breaking changes. These are production ready across Java, Python, and .NET. And so being able to have that trust is really key and a focus point of semantic kernel that we want to highlight. It's also multimodal. I chatted a bit earlier around customers that were starting to think around image and video and other mechanisms as well. Semantic kernel, right? We see a lot of customers and a lot of individuals who start with chat back and forth with an agent, but in customers' environments, they may have spaces where they can't use chat. They may be in development floors, in production floors, in manufacturing floors where they can't have access to typing and keyboards. And so being able to have that speech to text is really, really key. And so thinking of multimodal, of what are different mechanisms that will help. When you think about accessibility, right, being able to meet everyone where they're at and be able to not have something just focused on text, but chat or other mechanisms is very, very key, and a key part of semantic kernel that's a differentiator to be able to have that for all different modes that we're going through as well. And then the other piece will have a little bit in the modules and agents at the end that you'll be able to go through and work through, but really thinking about the future of once you get beyond chat and you get beyond each of these different modes, right? What can an agent be able to help you with? So having an agent alongside you that can help automate processes, right? For me, helping with blog posts, saving 2 hours of time to be able to go through, how can an agent that's working alongside you be able to help with that as well? And so just want to highlight, as we've chatted earlier, right, the semantic kernel really bridges between both the ML researcher and the app developer and really is able to bring the two of them together using Semantic Kernel. We've seen in the past that customers have not been able to have that key transition between the AI teams and the app development teams. And so being able to have Semantic Kernel in the middle that's able to have that handoff between where you can have all of your different models, all of your code, your memories, and be able to very easily get that into production. Copilots has been really key. And so with that, we'll go ahead and transition over to some of the Learn content and go through some of the modules there. Let me go ahead and switch to my other browser.
And it does look like we do have our first question, so we can go ahead and answer that. Eric asked, does Autogen use Semantic Kernel? So Microsoft's a big place. There's a lot of different SDKs out there to help you build AI applications. Semantic Kernel is Microsoft's enterprise SDK. It has those enterprise guarantees that Sophia described, and we'll see some of that in the Learn content and some of the demos that I'll be sharing later. Autogen is actually coming from Microsoft Research. And so their goal is, how do we build something as quickly as possible to learn what is possible with these LLMs, what's not possible. And Microsoft recommends, the Microsoft Research team recommends, don't necessarily use Autogen for production scenarios. But if you do want to kind of see what the cutting edge stuff, definitely check it out. And they do have agents that are powered by Semantic Kernel. If you do want to use some of the plugin, planner, and persona concepts that Semantic Kernel provides. The last thing I'll share is Sophia mentioned that Semantic Kernel is agent ready. What we've done and what we continually do in Semantic Kernel is we look outside of Microsoft and at what Microsoft Research is doing out in the wild. And what pushing the boundaries of what's possible with these AI applications, and we bring it into Semantic Kernel's SDK. So when we say agent ready, we basically took those exact same patterns of Autogen and baked them natively inside of Semantic Kernel while making sure that they were enterprise ready. Alrighty. And we have one other question, and then I'll let Sophia take it away with the Learn content. How is this different than LangChain? I would say they're very similar, right? It's an open source SDK that allows you to work with your LLM models in an easier way, right? LangChain was built in the Python world. It was built for AI developers and machine learning experts. And so the coding paradigm is a little bit more geared towards them. Semantic Kernel was built first and foremost for .NET devs, for enterprise devs. And so we care about things like dependency injection. We care about things like logging. We care about not breaking you. So us being V1, committing to not having breaking changes is huge. These are things that you won't necessarily find in LangChain. And so depending on your needs, if you need something kind of a little bit forward thinking and kind of similar to kind of the Autogen story, use LangChain. But if you need something to ship production ready applications, Microsoft's recommendation is to use something like Semantic Kernel. All righty, great questions. And
Perfect.
with that, Sophia, take it away.
Yeah, thanks, Matthew. Thanks for all the questions, and keep them coming. If there are other things that you're thinking through, feel free to pop them in chat. We'll have some dedicated time for Q&A at the end as well. And so diving into the Learn content, this is the page that you'd be able to see. We're going to dive into the develop AI agents in Azure OpenAI and Semantic Kernel SDK. So diving into the Learn content, right? I want to make sure that there are some prereqs that we recommend, right, of having that experience in C# and being able to have familiar with Azure. If you don't have that, no worries. We're going to walk you through everything. And so this is a really beginner-friendly course to be able to go through. But if you have familiarity with these items, that's great to be able to have as well. And so there are 6 different modules down here that you'll be able to go through in this learning path. Today, we're just going to cover the first 2 and be able to walk you through them. But there's a lot of other great content once you're able to learn about building your kernel, being able to create plugins as well. And we'll be able to then allow you to spend some time on your own to go through and create those AI agent skills that we were chatting about earlier, combining prompts and functions, and then being able to use intelligent planners, and finally be able to go through and create your AI travel agent. there's some updates that we're going through too in this content, right? Everything is moving so fast in the AI space. And so there's some updates that the Semantic Kernel team has on planners. And so you should be seeing that shortly too in the Learn content as well. So just wanted to make you aware of, if you come back in a couple of days, you see things different, right? That is just some updates we're going through in the planner space as well. And so diving into the first module to be able to build out your kernel, right? We really want you to be able to understand what the purpose of semantic kernel is, be able to go through some of the basics as well. We'd recommend that you go through and install some of the prereqs that we'll dive into. But really just kind of driving home again, Semantic Kernel is that open source SDK that Matthew was mentioning. It allows you to be able to integrate these large language models into your own code. And so being able to bring all those pieces of intelligent applications that we were chatting about earlier and be able to create apps using Copilot is really the key piece of Semantic Kernel that you'll be learning about here. And so there is a scenario for the final challenge that we'll be going through. And so you'll be a developer and you'll be in Margie's Travel, which is a travel and hospitality leader as well. And so you're going to be creating a personalized AI travel agent. And so rather than going through and creating all this from scratch and having to have your own large processing model, you'll be able to use Semantic Kernel in this experience as you're going through, and then be able to have an agent that will be able to help you with booking travel, be able to help you with more customized recommendations based on your travel as well. And so being able to think about that in real world, I know for me, I always am going through trying to do travel research. And so being able to see how you would create this and use it in the real world will really make it helpful for you too. And so a couple of prereqs we chatted about: if you have not installed Visual Studio Code, make sure that you have that installed. You're going to want to have dotnet 8 installed and some of the other prereqs as well, and be able to go through that. And so going into the next unit, right, Semantic Kernel and the agent framework, right? What is an agent, right? We chatted a bit about it, of being able to have it work alongside you, but having an agent that could be able to go through and write code for you, be able to help with automation, is really the key piece of Semantic Kernel and the AI agents before they're coming through. And so just really driving that home, there's so many different things you can do. I chatted about having an agent helping with blog posts for myself, but you're able to have it compose emails, right? Or be able to go through and provide recommendations as well. And so you're able to go through the rest of this unit too. I've covered a lot of what Semantic Kernel, but if there are any things that you want to refresh on or be able to learn more, you're able to go through this unit and dive in and learn a bit more. And then really why use Semantic Kernel, right? And why be able to pull it in. And so we chatted a bit about the ability to have multiple calls to an AI models, but what we really see is that it's great to be able to go and play with ChatGPT and be able to go into Bing Chat and to go into others and be able to make a single request and get that back from the model. But the power of being able to have Semantic Kernel, where you're able to make those multiple calls, right? Having multiple plugins that are in a planner and being able to have those requests go out is really where Semantic Kernel comes in, where you could have multiple processes that are going on and multiple data calls as well to be able to pull that together. And so it's really why we see the power of Semantic Kernel, of what's possible within AI, of not just going back and forth and asking a single question, but to be able to have multiple steps, right? Where you're calling your calendar, you're looking at those history pieces, you're being able to create an email. Is really that power. And so what we're seeing from customers, environments, and employees, they really are choosing Semantic Kernel to be able to automate repeatable tasks, right? Not having to spend the time going through things over and over again, having AI there to help you with that. Being able to give summarizations or key insights. We see a lot of customers who have documents that they're able to go through and have summaries, or be able to have Q&A and that back and forth pieces, and then be able to be more productive, right? Save more time for myself, right? Within blog posts, I can save 2 hours that I can spend somewhere else versus having to go and do all the research, be able to summarize and bring that in. And so for customers within Copilots, what we really are seeing is they're able to have those streamlined processes. It's available 24 hours as well. And they're able to go through and give personalized recommendations. And so we're really seeing that be able to have some benefits as well. So a couple of big things as well. you're able to take that learning curve down, right? There's so much happening with AI, and being able to have semantic kernel where the kernel and all these pieces are already built out. And then you're able to go through and make it very unique to you with a couple lines of code is really a key piece of that learning curve that we're able to help with within of why choose semantic kernel. And then that enhanced reliability, right? Being able to know that you're not going to have any breaking changes, that semantic kernel will be there to be able to help you with fine-tuning prompts and be able to go through those processes as well. And so if we go through the next learn module, so I'm going to come up to the top for the next unit within our learning. We're going to go through how you would go out and build your kernel, right? And what are the steps it'll take for that. And so I mentioned earlier, but if you haven't installed Visual Studio Code, you're going to want to do that before proceeding with these next steps. You're able to use a bunch of different AI models as well. Today we'll be focused on Azure OpenAI and all the great work there, but just want to highlight that it supports all these different AI models that you're able to update within your connector and play around as well. And so to get started, you want to go ahead and install the Semantic Kernel SDK. And so be able to go into Visual Studio Code, you'll copy this line into your terminal and be able to run that to get all those packages downloaded as well. And then for getting an Azure resource for Azure OpenAI, if you don't already have one, we'll go through walking through what creating that will look like for a deployment. But for getting your key, there's a couple of key things that you'll need once you have that created, right? We'll be chatting, we'll show a lot of different steps to talk about your deployment name and your endpoint, so your Azure endpoint and where that is located, then your very specific API key that it will call through, and then that model name of which model. And so it's really great to be able to specify exactly which model you're using. We see that, especially in customers' environments, that being able to have this piece that Semantic Kernel offers where you know the exact model that individuals are using and be able to pass that along is really key. And so within our next module, or our next unit here, you're going to actually create your endpoint. And so if you go ahead and navigate through to portal.azure.com, you would go and search for Azure OpenAI services and want to create a new resource as well. And so I'm just going to open up my portal to go through and show where you'd find the deployment, other things as well. But for deployments, what you would be able to do. So for me, I'm in Azure OpenAI, but you'll see over on the left-hand side where you would go for your deployments and then be able to click on this new deployment model to be able to go ahead and get that created. And so within that today, we'll be using the GPT-35-Turbo-16K. And so if you want to go and use that as your key model as you're going through and getting that created, you want to enter in a name for your deployment and call it whatever specific one you want to be able to give there as well. And then be able to have that go through and complete, and then navigate back to your Azure OpenAI resource as well. And so we'll be getting a couple pieces of information then under the resource management section of within keys and endpoint. You're going to want to save that to be able to have for later as we're going through the steps as well. And then just make sure that as you're going through the resource that you don't delete it. We'll have a couple of different steps to go through. And then once those are complete, we'll be able to have you shut off the Azure OpenAI deployment that you did, but you want to make sure that throughout the learning path that you keep this open as well. Before I go, I just want to make sure there are no questions and nothing to add, Matthew, from your end.
Yeah, one thing, if you don't mind going back to the Azure portal, it's probably worth just quickly showing where you can grab some of the information like that API key and endpoints. Do you mind showing folks where those are in the portal?
Yeah, definitely. So for myself, I go into chat and you're able to go in and see your different deployments, and you're able to then select the deployment. And so you want to select that GPT-35 one that we've specified down here for 35 Turbo 16K. You may have other deployments if you've been playing around, but you want to select that specific deployment. You'll then click up here of view code. And within here, you're able to get your endpoint. So that very specific URL, you're going to want to only copy to .com. And then you'll be able to copy your API key as well. and then be able to add in the model of that deployment name that you have for it as well, and any other pieces as well.
And I think that's the last bit. The deployment name is the piece that always tricks people up. There's the model name, which in this case is probably GPT-4. And then there's the deployment name. In this case, Sophia has deployed it, and it's called GPT-4-1106. And so when we ultimately create this connection with Semantic Kernel, we're going to be using the deployment name, not the model name. And Sophia, if you don't mind clicking on that view code one more time.
Absolutely.
If you ever get confused about what the deployment name is, you can see on line 6, there's a really clear kind of line right there saying, hey, the deployment name in this case is GPT-4-1106. Cool.
Perfect. I'm not seeing any questions that are coming in, but just want to make sure and pause if there are any questions that folks have.
This is the hardest part.
And yeah, it's the most, I feel like, cumbersome. Go through all the setup before you can get to the fun parts too, right? And so from that, then we're going to go through and actually build out a kernel and go through the next exercise with that. And so I'd mentioned this earlier, but if you have not installed Visual Studio Code, make sure to have that installed. There were some of the earlier packages you would be using in terminal. And then you also want to make sure that you have the .NET Framework 8 that's also installed. And then you may also need to install the Visual Studio Code C# Dev Kit extension. And so coming over next, we're going to go through how you would go ahead and create a new project. And so within Visual Studio Code, right, within here, you would want to create a new file, be able to go through and create those pieces here once it's gone through and gone finalized, and then be able to open up your terminal. So for a lot of these pieces, once you're entering in all of your endpoint, your API key, all those different pieces, you're going to make sure that you're in Visual Studio Code and be able to run through that as well. And so once you're in and have opened up the integrated terminal, so I'll just show very quickly how you would be able to open that as well. So within here, this is some of the content we'll get to in our next section, but within the terminal, you just want to come up to this window and go ahead and click New Terminal. And you'll notice down here, you're able to then copy and paste any of those lines of code and then press Enter to go ahead and execute through as well.
And Sophia, because your screen's a little bit light, we may want to bump up the screen size on VS Code. So if you go back to VS Code, if we do Control++ a few times, that should be a little bit easier for folks to see. Oh, did that work? Sweet.
Perfect. Yeah. If anyone has problems seeing, just let us know. Want to make sure you're able to see all the steps and all that as well. Perfect. So just coming back into a couple of the other steps and just really highlighting. So we chatted earlier around that deployment name, that endpoint URL, and then the API key, and then any of your deployment model as well. And so you're going to actually be creating a kernel using this piece of code. And so a really easy shortcut is being able to click copy here, and it'll just copy all the pieces you need, and you can very easily paste that into Visual Studio Code. You're going to want to take all the information that you were getting within your Azure deployment, within the deployment name, within the endpoint URL, and within the API key, and go ahead and enter it in to this step to be able to replace all those placeholders. And then once you've done all of that, you want to go ahead and execute that. And then to test that it's working, there's a line of code that you'll then be able to go ahead and copy. And once you've done that, you should be getting some really interesting responses. So this is invoking prompt sync, and it's asking for a list of different breakfast foods, right, that have both egg and cheese. And so once you run the code, you just want to make sure that you're getting back the responses that are similar to this, right? Quiche, omelet, other things as well, and make sure that everything that you set up has been working okay for that. Okay, and it looks like we're going to next section, next unit. Jamie, is there anything in terms of knowledge check that we want to do before we proceed with the audience?
It might be worth, so I do have that bit of code written. I can go ahead and show quickly what that looks like for folks. Um,
Perfect. Yeah,
Not
I'll
sure
stop
if we
sharing.
yeah. So let's go ahead. I believe folks should see my screen at this point. Is that right? Okay. Like silence is yes. Folks can see my screen. Okay. So as Sophia mentioned, creating a kernel is pretty easy. I have a kind of a helper method here that's actually running that piece of code for me. So adding either Azure OpenAI text completion or inside of this particular learn module, we're adding the Azure OpenAI chat completion. And I have a bunch of environment variables that are pulling in the right deployment name, the endpoint, and the API key. So that gets added to my builder. And I have some additional stuff, which we'll see later as Sophia talks about plugins. I go ahead and build my kernel. And then, as Sophia mentioned, I can use this invoke prompt async method to basically ask the AI, give me a list of breakfast foods with egg and cheese. You can see I've already kind of run this in the previously, but I'll go ahead and rerun it just so that we can check out what it's like. And it'll print out the results. And what's nice about SDKs, oh, there we go. It's running. What's nice about SDKs like Semantic Kernel is if you were to use the, I like to say, raw APIs within Azure OpenAI, you're writing a lot more code, right? In Semantic Kernel, we make it super easy where it's just like a single line of code to invoke a prompt, and then you can, of course, print it out. So that's thinking. There we go. Yeah. And just like Sophia showed, kind of the output there is a list of those different items. Because I'm using GDP4, it's a little bit more verbose. It's telling me some kind of information about those different breakfast foods that include eggs and cheeses. But this is, to me, the fun part of using AI is giving a prompt and seeing what comes back from that AI. Alrighty, I'll pass it back to you, Sophia.
Perfect. Thank you so much, Matthew. And Jamie, I'm seeing we're having a couple of questions if we want to go through those before going through the next module. Great. So I see a question from Eric. Is there a cost for running these examples with Azure? So as you go through and set up your Azure OpenAI subscription, there is a cost with running that, right? There's tokens, and we'll kind of learn more about that as you're going through, but there is a cost with going through and setting that up. And so just realize there's kind of those notes throughout the module that says make sure to keep it running for the different deployment throughout the exercise, but you want to make sure after you're done to go ahead and shut that off. If you have any other further questions, feel free to put them in comments too. We'd love to hear from you. Great. And we see a question, is it possible to create an AI using Ollama? Absolutely. And so one thing that I was chatting about earlier with Semantic Kernel is we're able to, within one line of code within connectors, change which connector and which AI models you're using. And so you can absolutely use Ollama and be able to change and use different AI models with that. Matthew, anything to add from your end?
No, to me, this is another part of Semantic Kernel that I love. We have so many connectors to different AI services. Ollama, for those that are familiar, is kind of a local way of running AI models. So to the previous question, if you really are cost conscious and you just want to like try things out without having to pay Azure any money, you could go read our documentation, check out how to use the Ollama connector, and get started that way.
Perfect. I see a question. Can it handle structure, output, and function calling? Absolutely. And so we're going to dive into a bit around some of the power of function calling. But one of the key planners, if you go through and learn a little bit more about Semantic Kernel and go through our repo, is we have automatic function calling, a lot of that baked in. I'm curious if there is a specific scenario that you may have that we can chat about further, but it absolutely can handle that.
And again, this is kind of where Semantic Kernel really starts to shine. A lot of the complexity of building AI applications is using something like Semantic Kernel and handling a lot of the structured output that is coming from the AI. Because yeah, it's a structured output, but it's this huge string that you then have to parse, kind of break down into pieces and pass into your functions. In semantic kernel, that's hundreds and hundreds of lines of code to make sure that it's reliable and error-free, or as error-free as you can be with these LLMs. And we want to make sure you're able to use something like semantic kernel so that you don't have to write all that code yourself.
Okay, great. I see another question. The individual has a use case where they need to automate the process of reviewing quote unquote product reviews provided by customers. OpenAI has an endpoint called moderation to check for text moderation. So, yeah, absolutely. Being able to go through and summarize is definitely a piece of that. And I see there's a bit more of the question as well. However, I'm unable to automate this process using semantic kernel because SK doesn't seem to support any functionality on top of moderation. Is semantic kernel not designed for use cases like that?
Semantic kernel doesn't seem to support any functionality on top of moderation. I don't quite get that question. I don't know, Sophia, if you do. But the OpenAI services do have some responsible AI features that you can enable. And if you check all those boxes, semantic kernel will just kind of honor those and use them, and they'll do content safety checks. If you want to do additional rules like, hey, AI, don't talk about these things, or avoid these topics, or if a user asks for this, is inappropriate, you can add all of that inside of the prompt to make sure that your AI isn't doing anything inappropriate.
Yeah, absolutely. That was going to be my kind of dive into. So I think if you have further questions on that, let us know of what you're specifically wanting them to review. But all those things are possible with semantic kernel being able to make sure if there are things that you want to have, like it's a workplace appropriate application, other things like that, you're able to give the AI all of those specifications. And before we go on, let's just see if there are any other questions. I'm going to get my screen share out to go through the next module as well. Great. Well, if there are no other questions, I'm going to go ahead and share out screen. We'll go through our second module. Great. And so there are 5 other modules after you go through the basics of getting semantic kernel up and running. The next one that we're going to dive into before we leave some time at the end for Q&A is being able to create plugins for semantic kernel. And so we want to be able to understand, we've been chatting about plugins and what's possible a little bit more there. And so when you think of plugins, right, it's just the ability to be able to call data, be able to pull in all those pieces using APIs as well. And so diving into learn a little bit more around that. So we've chatted about a plugin of being able to use APIs, be able to call data, but we're going to go through a couple of built-in plugins in detail and be able to really specify that. And so for using a plugin, you can add it to a kernel and then call the desired function using the invoke async method. You'll see that in a lot of different code samples as you're going through. And so it's being able to locate and run the function and then be able to give the results back to you. And so as we were chatting earlier and showing some of the different plugins, there's some of them that are just built in that I want to highlight in particular. There's the conversation summary plugin. So being able to take a long conversation, a big document, be able to go through and summarize everything that's going on. There is also the file IO plugin. And so being able to read and write to file share systems and be able to get that information is really key, especially as you're going through different file locations and being able to get any of the files to read through. And HTTP endpoints, being able to make that request through the HTTP plugin, be able to get information has been really key. Another plugin to be able to talk about is the math plugin. So being able to have math operations, doing addition, other pieces like that that you may need as you're going through is just a built-in plugin that you don't have to go through and create that we offer as well, which is a key piece of semantic kernel. The example below talks about the time plugin, but being able to get back any sort of time or date information is always very key, especially as you're going through in the example with a travel agent and being able to understand for different dates, different time as well. There's a wait plugin. So being able to pause execution for a specific amount of time. You may have report that you're wanting to pull every hour, and being able to give that specified amount of time to pause for any sort of execution is a really key to be able to go through and pull that in. And so just diving into what the code looks like, right? We have all the information around using semantic kernel, using the plugin, and using those core pieces, but being able to then have the AI deployment and the specific type of endpoint key and API key to be able to then do all this work. You'll enter that in as you did in the previous task. And then after that, you'll be able to then call the time plugin that will be able to then call the day of week function. And so be able to get back and return to you as a user, what is the specific day of the week, and be able to return that back using some of these built-in plugins. So instead of having to do lines and lines of code, you're able to very easily get this returned back from AI as well.
Right. And if we bounce back to my screen, we can kind of see this in action. So what we're looking on the screen right now is, again, we're building our kernel. The new bit of code that I'm writing here is adding that new time plugin. As we saw in the Learn article, you do have to import this new package. So you'll need to include that. These are kind of experimental plugins, so you'll have to add a pragma warning at the top saying you want to use it. And as we saw in Sophia's Learn content, we can invoke this and get the current day, which is, in this case, Thursday, right? If we look at the time plugin, we can see all the different types of functions that it has available, getting the current date, the current day, now, et cetera, et cetera, et cetera. Now, one area, Sophia mentioned that we're going to be making some updates to our Learn content. You might be thinking, why am I using the kernel just to invoke some code that I could easily do myself? The value of plugins isn't for you to just invoke them yourself. It's actually to give them to the AI so that the AI can be the one that invokes it. And so I have some lines commented out over here. And we're just going to get a taste. We're going to see some more of this as we go through the Learn content. A taste of the AI using these plugins instead of us, the developer. Okay, so I'll go ahead and comment out these lines. And what we're doing here is we're using that time plugin, and we are telling the AI that we want it to automatically invoke any of our plugins, any of the functions inside of those plugins. And so now when we ask the AI to tell us what time it is, it's actually going to be smart enough to use the methods, the functions inside of the time plugin to provide an answer. So I'll go ahead and run this. Excuse me. And since I've enabled logging, we can actually go to the debug console and see what it's doing. Because it doesn't know the current time, it called our time plugin. It got now, the current now time. It succeeded. This is the information that our plugin provided back to the AI. It's Thursday, August 29th. And then if we go back to our terminal application, we can see that the AI responded back with the correct time. It was able to use that information to provide an answer. And if we didn't include this time plugin, just to check out what the AI would do, it doesn't have that information. It can't retrieve that information. And so it's going to respond back with something like, I'm not able to provide this real-time information, right? So there was a question about function calling. This is function calling in action and the power of creating plugins and giving it to the AI. Okay. All righty. So hopefully that got you kind of excited about what plugins can do. And we just saw what one of the out-of-the-box plugins allows your AIs to do, as Sophia mentioned. All righty. Back to you, Sophia.
Perfect. Thanks, Matthew. Before we go through the next unit, I just want to pause if there are any questions. The next unit will really be going through your environment and diving into that. So just want to pause if there are any questions that folks may have. Yeah, there's one that if I have a large business model that can be represented in JSON, what are the strategies that one can do in AI to work against it due to token limits? Yeah, that's a really good question. I know that that is one thing we haven't talked about yet, but token limits are big, right? There's only for tokens, there's only a number of characters that are in each token. And so as you have very, very lengthy documents, very, very lengthy calls, right? It can eat up a lot of tokens. I think the key piece that I would really highlight is being able to go through in memory and be able to store some of the information. So if you're doing multiple calls, right, how can you be able to not use up your tokens every single time on that, like you're saying, JSON, be able to go through and pull that in. So I think for moving forwards or making multiple calls, having that in your memory, and we'll chat about that. There is some more work, and as you're going through on your own later in the modules, where you learn about memory, but that can really help with tokens and being able to keep the cost down.
Exactly. And to Sophia's point, it's about finding the right context, not always providing everything to the AI. Yes, the models, their token windows keep getting bigger and bigger. So really, I wouldn't expect you to hit token limits as much as we used to a year ago. But it does add latency and it does add cost. And so if you do have a very large business model, start identifying strategies of saying, do I really need to send all of this to the LLM? Do I really need to provide all this data? And likely it's not, right? And if you use something like memory, the AI can search for the information that's relevant, not include all of it. And if you're generating this business model, right, maybe the AI does have to create all this content to submit into a form, right? My recommendation is don't ask the AI to do too much at one time. That's a recipe for hallucinations and bad results. If you can break up a task, if you can say, hey, AI, create this chunk of the business model, create this chunk next. You can break down the problem. The AI is going to perform more accurately, and you'll be less likely to hit some of those token limits that you may be hitting today.
Great. I see another question that came in. Wouldn't the solution to just create a plugin to call the moderation APIs? And so this may be back to that earlier question that we were seeing as well. That's a really good suggestion. Really love when we see the community helping each other out. But there is the ability to be able to have plugins and to be able to create that, like you're saying, to be able to call different pieces of data. And so that definitely within those reviews to be able to go through and call through different plugins is definitely a great suggestion. Appreciate that.
The one thing I will caution is one, I love plugins. Like create a plugin for everything, throw it at the AI, and magic kind of happens. The one thing I will caution is there are some things that you don't want the AI to be in control of, right? Things that you need to happen every single time for compliance or risk reasons. There are probably cases where you want the AI to decide if moderation is needed, right? Sometimes there's cases where you do want an image of the competitor so that you can do some compete analysis, right? And you want the AI to be smart enough to go, hey, this is an okay time to use this image, and maybe another time that's not. Most cases, though, you always want it to run in the background. And so that's really why I love the toggles instead of Azure AI Search that just enable moderation and some of those content safety checks, because it means it's happening every single time. We're not going to be covering it as part of the getting started materials, but we also have this concept of filters. I know Sophia loves filters, but it allows you to have some hooks that always run every single time. That might be another good place for where you would want to add this moderation capability.
Great. And I just want to highlight, there's another great question I'll come back to in one second. I want to highlight our blogs that we have down below. And so a lot of these are great scenarios that we dive into further in docs and blogs, but just something to highlight as well to be able to go check out. See, we have a couple more questions. Would love to dive into them. Great. I see one from Eric. Aren't embedded vector databases used in RAG apps to lessen the calls made to the LLM anyway?
Yes. And this kind of goes back to what Sophia was describing of using memory. Memory behind the scenes is using these vector databases. And so what we were describing earlier is using them just to pull in the right context to do something like RAG, retrieval augmented generation. But there's also a concept of semantic caching. Again, we're not going to cover that as part of this learning material. But if you cache results inside of a vector DB memory and retrieve that memory, sometimes that's already the answer. And so you can immediately send that back to the user without having to make any LLM call and spending tokens or wasting time.
Great. Any other questions that we have before we dive into the next unit?
I don't think so.
If not, keep them coming. I'd love to be able to spend some more time going through that. So now building on seeing the plugins, we're actually going to go through and prepare your environment and actually go ahead and create that as well. And so for this, I mentioned earlier and just want to reiterate, right, you want to make sure before proceeding that you've installed Visual Studio Code, you have .NET 8, the framework of that installed as well. And then you may need to come into Visual Studio and come into this section over here. I always say it looks like building blocks into extensions, and you may need to install that .NET extension pack as well. And so just recommend that you go through the extension and the dev kit and extension as well to go through. And so for the next piece, we're actually going to go ahead and clone the repo and be able to go through some of these pre-made files as well. And so in Visual Studio Code, what you're going to want to do is once you open it, you're into this very easy to go through screen, right? And so you're going to want to click clone the GitHub repository button here under start. And you're going to notice up here at the top that a search bar pops up looking for the URL. So what you're going to want to do then is take this URL, copy it, and go ahead and enter that in. Once you do that, I've already done it. I'll show you kind of the final steps of what that looks like. It'll open up your file explorer and will create a folder and a location. So you just want to choose a location that is easy to find for you, being able to go through that as well. And then click the select repository destination. Another key thing that wasn't highlighted above, but just make sure you're signed into GitHub to be able to clone the project successfully. If not, you may encounter some issues as well. And so once you've done all those steps, you're going to have it pop up like this. So you'll have all of the different folders, all the different files from that repo here. There's a couple of different modules. We're in that second one. And so you want to expand this down that little arrow. And you'll see that there are some different pieces in here. You're going to want to click on the program.cs in order to go through and add in all of those secret pieces that you're using, right? Your deployment name, your endpoint, your API key that we've chatted about earlier, and be able to add that in before going further. And so coming back to the instructions, as you go through in that program.cs file, you'll want to update all those pieces. And after that, then you're ready to go, right? You're ready to go through and actually try running your first piece of program and be able to dive into that further. And so in the integrated terminal, and we chatted about that earlier, right, of down here, you're able to easily copy and paste and be able to see outputs as well. There is a line of code here that you'll go ahead and copy and go ahead and run in order to be able to get to the next steps. And so then in that program.cs file, you're going to want to add in these pieces of information. And so you're really being able to have a plugin and be able to have that conversation summary plugin that we talked about earlier, and being able to really summarize and take the key pieces away. And so you're able to then in your string be able to really add an input. And so for this scenario, right, you're vegan in search of new recipes and you really like spicy food. And so you're wanting a list of breakfast recipes that are vegan friendly. And so with that, you're able to have the conversation summarized, be able to go back to invoke sync and be able to get the actions and the input here to be able to go through all those pieces there.
And if we want to see what this looks like running, let's do a quick switch over. So I have my conversation plugin, we have our inputs, and we're invoking the plugin with this input. There's a couple things I want to just highlight that we're learning as part of this additional built-in plugin. One, this is a smart plugin, right? It's taking in this input and it's actually going to summarize it. So behind the scenes, it's using an LLM call. I like calling this out because a lot of people, when they start thinking about plugins, they're thinking, oh, it's just a bunch of like my existing APIs. But they can also include additional intelligence. In this case, it's summarizing this input. I really like it whenever I'm building something like a Bing or a search plugin, because if you just take all of the results from Bing and you just give it back to the AI, that's a lot of wasted tokens. And so summarizing it beforehand with an additional LM call can reduce the number of tokens that go into that final AI that's supposed to provide you an answer. Okay. The second thing I want to kind of call out is plugins can have inputs, right? Our time plugin didn't have any inputs, it just got the current date, right? But if we come to the conversation plugin, we can see this summarized conversation is sync. It actually includes this input string that we're going to provide, and kind of a description of what this input requires. And this is all communicated to the AI if you want the AI to actually use this function inside of itself, right? So of course, as part of the training material, we're just going to invoke it manually, right? And we can see there's kind of a this JSON that gets returned back, similar to what you're seeing in the learning content. But if we wanted to have the AI use this plugin, we could do the exact same thing that we did earlier, where we're turning on automatic function calling. Let's go ahead and comment this part out. Please summarize this content. Summarize this content using the summarize function. And I'm skipping ahead a little bit. We're kind of seeing what it's like to input some additional parameters. Okay. And now if we run this, the AI should, fingers crossed, use the function, or sorry, the plugin that we added in order to actually summarize the input, this input, for the user. So we're waiting for it to run. Here's a summary of the content. The individual is a vegan. And if we go back over here, we weren't lucky. Sometimes the AI thinks it's smart enough that it doesn't need to call functions. So let's please use, let's see, we're going to force it real quick. Plugin, use the summary function in the conversation plugin, and we'll go ahead and run this one more time. Okay. Some of these plugins that we introduced in Semantic Kernel in the early days were necessary when the AI was not as good. But as AI has improved, what we've noticed is some of the things that you used to require plugins for were kind of less necessary. So we can see here. It called the function, I think. Yeah, somewhere. Yep. And then it got this response and pasted it out. Okay. Cool. And with that, I want to go ahead and pass it back to Sophia.
Perfect. Thanks, Matthew. So going from the Unit 3, we're going to dive into Unit 4 next, of how you can optimize language models and prompts for that as well. So prompts are really those conversational cues and being able to give that specification, right? So in the previous unit we just covered, you went through and created all the different input string here. You can be able to modify that, as you can see, and be able to really make that unique to your information that you want to have for your AI. There are a couple of tips that we want to go through and really highlight. Is have fun with it, experiment, right? Be able to go through and really understand how you get responses back. Do little tweaks like you were seeing Matthew do. Go through and learn and try going through that. Having very specific inputs gives you very, very specific outputs. So if you're very open-ended of give me every result of X, right? It's going to give you so much information where if you give it a very specific date of, I want to be able to get the Bing background image from today, right? And be able to give it a very, very specific parameter. The output is really determined based on the input that you give as well. That context matters. And so being able to give the pieces that it'll need, right, of around you like spicy food as well, it's able to really specify not only vegan food, but then spicy foods, and really being able to give context in that instead of going to every single vegan recipe. And so being able to give context is very, very key. For ambiguity, make sure to go through and avoid vague asks to not get unexpected results, right? You can really be able to define your AI a bit more by giving parameters. For me, if I go and search for, give me a list of restaurants, right? It's very, very open-ended, very, very ambiguous of what is the type of cuisine, where is the location. So being able to go through and give it very, very specific pieces in your prompts really helps. And then if you have shorter prompts, right, we don't want to have too long of prompts. If it's too lengthy, there's just too much information that's provided. So being very, very succinct and to the point really, really helps within that as well. And so when you're creating your prompt templates, you'll be using these curly brackets and be able to pull in the information that's used to be able to get that as well. And so in the below example that you can go through and run, you'll enter in all of your information as we've been doing in the previous steps as well. But the string really talks about a family with diverse taste buds. So diving even further from the vegan food example, right? There's a mix of picky eaters in this family, and there are allergies, and they're wanting to explore vegetarian recipes. And they then go through and specify within picky eater, what does that make, right? It's not ambiguous of they have an aversion to anything green, right? And then the allergy, they're coming through and specifying that they have a peanut allergy, right? Just to make sure that any of the meals don't include peanuts, and then be able to really get flavorful plant-based food as well with the vegetarian mix. And so being able to go through and store all this in the history, you're able to use, as we chatted about above, the curly brackets to call all this information that you've provided as well. And so the example output that you may get if you run this piece of code, you may get a lentil and vegetable soup, right? That doesn't have greens, but doesn't have peanuts as well, cauliflower steaks and others. And so it's a great way to be able to go through and test and be able to give a bit more specifications to AI in that.
Great. And we do have some questions that I actually think this particular page is showing you how to address. So Corey asks, what are the options for using semantic kernel to add and work with RAG queries? If we jump to my screen real quick. So in Sophia's example, you have some like history. We have that prompt. We use those curly braces to pull in additional information. We in Semantic Kernel, we have some other abstractions that allow you to easily search for data within a vector DB, like Azure AI Search. I am not going to code that on the fly because that is highly risky. But you could imagine that we have a bunch of chunks, right? And that would call that search to Azure AI Search and get a bunch of information back that we can provide the AI. So maybe these are chunks about chunks from available recipes, right? And what I'd expect a query to Azure AI Search to include are things like this list of options, right? And if I want to do something like RAG, what I can do is just like how I'm using these curly braces to include this history, I can also use curly braces to put in any of the chunks that retrieved information from Azure AI Search. And then if I go ahead and provide this information here, there we go. When I now run, okay, it's not happy. Oh, yep. Okay. Now, when I run this, my prompt that I'm sending to the LLM is including both that history and those retrieved chunks. And if you're interested in how to actually retrieve this and not hard code it, keep following kind of the Learn content after today, or check out our Learn documentation. And if we wait just a tad longer, we should get a response, and it should leverage some of the recommendations that were part of these chunks. Okay. And if we scroll up here, let's see, is it, we might have to flip this around to something like, these are the available recipes from the user's kitchen, preference these first. Okay, and then we can run this one more time. And then that should provide a little bit more guidance of how to actually use the information that you retrieve. As we just saw, if you just dump a bunch of chunks, the AI might not know how to actually use it. And so what we're doing here is providing a little bit more context to the LLM so that when it finally does respond, it does so correctly. Okay, let's see, moment of truth. A lot of what we're doing right now is on the simpler side, where we're just using invoke prompt async. There is a streaming version, invoke streaming async, if you want this text to come back faster instead of having to wait forever. We are not showing that right now because we just want to help you get started. But just know that if you're like, wow, this is really slow, we do provide within Semantic Kernel the ability to stream the responses back. And if we take a look at the response, we can see that it prioritized those things that came from those chunks. And then it provided some additional recipe suggestions, since I said, hey, preference these first. That implies that there's other things that can be recommended. Alrighty. With that, I think we might have had one more other question. Let's answer that real quick. And then Sophia, you can take it away.
Sounds good. I see a question from Sarosh. Can we use Semantic Kernel and OpenAI to drive a chatbot using your own PDF docs without using Azure OpenAI? Absolutely. So if you're looking to use different models, you're able to change that within connectors. But let's say that you're wanting to run a small language model versus having to make the call and have the cost of all of these AI models. You are absolutely able to do that and be able to create a chatbot and be able to go through and pull using RAG within your PDF documents to be able to do summarization, Q&A, other things as well. But you don't specifically have to use Azure OpenAI. It's a great tool that provides you with so many additional benefits and all the greatest and latest within ChatGPT and some of the models there, but you don't have to. And so if you are looking at this today and wanting to try around with different SLMs or LMs, you're not just forced into one.
Perfect question. And then Eric has one more kind of in the RAG space. Is there a connector, I would say a plugin in Semantic Kernel for searching things like Bing, Copilot, or Perplexity? We have a PR out as we speak for that plugin for Microsoft Bing. We don't have anything yet for Copilot or Perplexity, but you can imagine that's something that we'll want to include on our backlog. Great question.
Great question. Yeah, keep them coming as we're going through. Really appreciate it. So we're going to dive into then the next unit, going into unit 5 and being able to go through and actually write your own prompt. And so being able to go through and take all the latest that you've been learning and be able to actually put it to use. And so you're going to want to open Visual Studio Code, the project that you created in that previous exercise. And then you're going to want to come back into that program.cs file that we were in earlier and actually be able to add in these other pieces of code. And so you're able to have the ability to have language translation. And this is really where we're showing to be able to have Traveler, especially to the AI app that you're going to be creating around travel and creating of being able to have content in other languages, being able to get a list of how to say different words as well. And so within this, you can see that the string language is changed to French. And then within the prompt, it's asking the AI to create a list of helpful phrases and words in language, right? Calling back this language that we just sat in French, a traveler would find useful. And so being able to go through and run that, you should be getting back responses then in French of bonjour, merci, other things as well, and be able to have that translated back and forth. And so it's really great, again, everyday use, right? If you're going to a new country or you just wanting to learn more about specific languages, of what are helpful phrases to be able to have with that as well. And so within the prompt, then you can be able to then group different items as well and be able to specify in your prompt even further. So taking it beyond just getting helpful phrases back, of group by category, and display the phrases in the following format, which you see up above, hello and bonjour, and be able to get back and forth between both of the languages as well. And so in the prompt, you can provide the LM with specific instructions to format, and you can get specific outputs of if you want for grouping based on restaurants, so being able to order, asking for water, the check, other things as well. You can even group by transportation, being able to find things like metro, and be able to really easily find, instead of having a huge long list of items, be able to have them grouped by areas that you'd want to very easily be able to access as you're traveling as well. And so you'll then go through in your exercise and be able to update again your prompt and be able to add in the language of French, but then be able to take what we've been working on earlier around some of the recipes and some of the allergies and other things that the family has, and be able to add that into your string history of that one of your children has a peanut allergy, and then consider the traveler's background and be able to call back the history that you have stored here, of being able to build on that, right? Be able to get helpful phrases and words that are in French the traveler would find useful, be able to then group by category, right? And be able to have them by transportation, restaurant, and then be able to go through and display those different words, but then be able to make sure that they're able to share that this individual has a peanut allergy and be able to have phrases for that as well. And so before we go on, are there any questions that folks have? I know that this is a lot to kind of build on and go through. Are there any questions individuals have around some of the prompting and some of the specifications there? Just looking through questions. If no questions, we'll go on to the next unit then.
Let's do it.
So from there, we chatted earlier around personas, right? Of really giving AI that job description and really specifying, but we're going to dive into what personas looks like in prompts. And so being able to really improve the quality of responses that you get back and be able to give that context. And so you'll go ahead and move forward within Visual Studio Code. You'll have all of your information, all of your secret information that you'll have stored up in here. And then you'll be able to see we're taking a lot of the code that we've been using prior and just building on top of that, right? That was the foundation block, and able to then add in the persona and some of the prompt thereof. You are now a travel assistant, you're helpful, you're creative, and you're very friendly. Consider the traveler's background of the history above of the peanut allergy. And so really giving it the personification of what is its task, right? It's going to be very, very helpful, very friendly, as you would hope as you're trying to go through and plan travel as well. And so being able to give that specification, that persona, you're then able to create a helpful list of phrases and words in French or whatever language you want to change it to that a traveler would find useful, and then be able to group that together as well. And then you can give the specification of have any of the outputs then begin with, here are some phrases in the specific language that you might find useful, and end with, I hope you find this helpful on your trip, to really go back to the persona of being very helpful and very friendly as well. And so what you should see after you run that code in your terminal, you should get back a response that has that key phrase first of you may find helpful. They're grouped together by the different areas from above. It takes in the history of being able to look through the peanut allergy, of how to specify that, and then ends the output with, I hope this helps you on your trip, right? And so really making AI a little bit more personified, a little bit more like that helpful agent that's working alongside you. And so as you're going through, you can then be able to update your message as well and be able to have the message from both the user and assistant in mind. So a lot of the times there is from the user what you're sending over to the assistant and to AI. And then there's a lot of system messages as well that will get added in. And you'll be able to see some of that in the background as well as you're going through the modules. But within this, you can be able to have back and forth of giving it that prompt of use this conversation for an AI travel assistant. They're helpful, creative, and friendly. And the user can ask, can you give me some travel destination suggestions? And then the assistant would kind of start to converse back and forth and be able to have that conversation of course, happy to help, right? Do you have a budget in mind or any other activities in mind where you're able to then have that back and forth from the user and the assistant? So as we're going through, I'd love to see, I'm just looking in chat if there are any questions.
Yeah. And I think what's really key about this particular section is what we've done so far is kind of just provide some text and giving it to the LLM. Behind the scenes, we're using something called a chat completion model. And so what we are doing behind the scenes is turning it into a chat message so that the AI can predict what is the next chat message that it should respond with. As you get more advanced, you want to have that extra control of defining multiple messages or messages with different roles. And so what you're seeing with Sophia's example is we can start saying, hey, this is a system message, this is a user message, this is an assistant message. And you can basically control a little bit behavior that the AI has. If we bounce back to my screen and kind of see what it's like, excuse me. We saw in some of the previous examples, and we saw when I was like live coding some of the stuff that people asked, sometimes the AI didn't actually do what we wanted it to do. And that's because the AI is always prioritizing the system message, the secret whispering that we tell the AI of what it should or should not do. And this is always prioritized over what the additional messages have. So for example, in this particular system message, we say identify the from and to destinations and dates from the user's requests. If we just ran this section right here, it would succeed because the user is providing some information. It's saying, hey, these are my travel dates. The AI is able to do that. The challenge, however, or the benefit of having a system message is, and we can see it provides some answers from Seattle to Tokyo and the correct dates. What could happen is the user might be asking for something that isn't something that you want the AI to answer. So for example, this particular input that we're providing here is, hey, I'm planning a trip. We like all these different things. Can you help us out? Our travel budget is $15,000. If we run it a second time, because this ask is not specifically something that the AI is permitted to do, which is only to identify the from and to destinations, it's going to basically give you an error, right? Hey, this doesn't provide any of the information for me to actually help you, right? And so this can be a really great way of you providing some guardrails of what the AI can do. We kind of talked about some of the moderation before. If you wanted to add moderation into the prompt, you want to make sure that you're providing it inside of the system role message. All righty, I'll pass it back off to Sophia.
Perfect. Thanks, Matthew. See, there are a couple of questions in chat that we can dive into before we go into the next unit. From Eric, love to chat. So the question is there a dynamic way of updating the persona agent prompt instead of changing in code, compiling, and retrying? Absolutely. As you're going through, there's the ability to be able to update and just have that as the system message as well, and be able to have that where you don't have to go through and update it every single time. Matthew, anything else to add from your end?
Yeah. If we jump back to my screen, what I like to do is use the kind of squiggly line approach that Semantic Kernel provides. Input, and then sorry about this persona. Okay, so this is kind of how I like to make things a little bit more dynamic. Is I can have a property called persona or variable, and then I can inject it into this template. We've been showing you kind of like Semantic Kernel's out of the box templating language, which is pretty simple. If you wanted to use something like handlebars or liquid, you can even have like for loops in here to print out multiple messages. But this is kind of the way that you would have something more dynamic that you could then run whenever you wanted. Great question. Were there any other questions?
Oh, there's another good one. How do you prevent jailbreaking? Probably a bigger discussion than this session. It's really, really key, especially in the security space, right? There's a lot of those responsible AI principles that are just baked in. The dependency injection, there are a lot of other samples that we have that really highlight the security of semantic kernel. I think there's definitely a lot that we're doing over time to make sure that there isn't anything that you can go through and jailbreak into. But if there are kind of specific scenarios or that you're wondering about, happy to dive in. But there's a lot of those security principles that are baked in.
And not just in semantic kernel, but also within the services themselves. So if you are using Azure OpenAI, they have a relatively new feature called Prompt Shield, right? And it's been trained to actually detect some of the most common jailbreaking techniques. And then we also kind of mentioned filters before. If you want to go above and beyond, adding a filter right before an LLM call is made to basically have another LLM call to go, is there a jailbreak being attempted here? That could be another good way of preventing something nefarious happening. Cool.
Great. Well, with that, we'll go ahead and dive into our next unit. We have 2 more units in this section to go through. This is really how you're going to save your prompts to files. And so you learned about the kernel invoke prompt async, where we chatted about being able to use streaming as well. In this sample, you're going to go ahead and copy this line of code and go ahead and be able to test and try out, right, of different fantasy characters, being able to have some of the history there. Within creating plugins in semantic kernel, the plugin template is just some simple syntax rules. So you don't need to write code or be able to import external libraries. The curly braces that you've been seeing throughout in Matthew samples, you'll just be able to use that to be able to go through and have expressions in your prompts. And so to create a semantic kernel plugin, you'll need a folder that has 2 files. You'll want a text file and then a JSON file as well. So the text file that you would be going through and creating, that contains where the prompt to the large language model is, and similar to all the other prompts they've been writing so far. And so being able to have a text file, and then the JSON file just has all the config details. And so it would be able to support the following parameters of having the type, right, of what specifically you want to use in the chat completion prompt type, the description of what the prompt does, right? You've been seeing in the example prior, all the different prompts that you're able to add in as well. You're able to then add in the input variables in that JSON file as well to really be able to define what the different variables are that may be used inside the prompt. And then finally, that execution settings. So being able to have the settings for completing the model and being able to have the max number of tokens. So I know we had a question earlier around how do you make sure that you're not calling and having huge token limits. You can be able to set token max. So, right, if you have cost pieces that you're wanting to adhere to, you're able to set what the max number of tokens are and temperature properties as well. And so diving into our example down here, here's a great example of our text file, right, which has the system message, the instructions, and the details of what the agent is focused on. And so being able to be a helpful music theory assistant, providing the user with several chords that they could add to chord progression based on starting chords, and really starting with that prompting message, and then being able to have from the user the kind of start back and forth to the assistant of what are the different all up chords that they're wanting to get, and be able to return that back as well. And then just showing a kind of further example, building on those concepts above for a JSON file, right? You see all the different inputs we were talking about, the type of having it be a completion service for description, recommend to use the user's use chords based on the user starting chords that they give, and then max number of tokens at 1,000, and then temperature at 0 as well. And so with that, then you can be able to use your input variables, have the starting chords called, and be able to go through and define that of what the description is and if it's required true. And so within this, you're really starting to get into the heart of semantic kernel of beyond some of the examples of what will be some of the config that you would go through and do.
Awesome. And if we switch back to my screen, we can kind of see this in action. All the code that Sophia showed. I have in here this prompts folder, and I have those 2 files that Sophia mentioned, that config file that shows the, excuse me, those inputs, and kind of that actual prompt over here. And then when I import this and run it, we can see these recommended chords being provided to us. Why would you create these other files to store your prompts instead of just hard coding it into your program file like we have been? The main value is, as Sophia was mentioning, one of our goals is to bridge that chasm between AI developers and app developers. A typical workflow that we've seen happen in companies is the AI devs will create these files, your config files, your prompts. They will massage these prompts to make sure that they actually do what they're supposed to do. They'll do things like evaluations. They'll come up with all their fancy scores and go, yep, I have determined that this is the best prompt to answer the types of questions that we need in our AI application. And instead of asking a .NET dev like yourselves to recreate all of this code, all they have to do is pass over these files, these text files, and then you can import them into your own application so that you can, excuse me, start using them immediately. And one of my favorite things to see is actually AI devs and professional devs, app devs, working in the same mono repo. And y'all can both point to and reference the exact same configuration files, no matter if they're using Python and you're using C# or .NET. So that's a really powerful aspect of semantic kernel, is kind of the interoperability when it comes to our prompt files. Okay, cool. I'll pass it back to Sophia.
Perfect. Thank you, Matthew. Thanks for walking through that. I do see we have a question if we want to pause for that for 1 second, because the next piece will just be walking through the exercise that you have from the saving prompts to files as well. So there's a question of what is the recommended way to work with memory in semantic kernel and .NET? It's been a little confusing for me to know whether kernel memory or semantic memory is the recommended approach to take. It's a really great question. We recommend using semantic memory. Kernel memory is another piece and another research project, as we were mentioning earlier with AutoGen. So there's a lot of great pieces that are getting baked in, but if you are going through and making applications in your production environments, we recommend using that semantic memory. And so it really is the recommended approach to take. The kernel memory has all the greatest and latest research, but it's not ready for production environments. And so a lot of that is getting finalized and baked in. We're going to be bringing the best pieces of kernel memory into semantic memory as well. And so that really is the approach that we recommend. But no memory, there's a lot of confusion, right, for me even learning through of what's happening behind the scenes. And so if you do have further questions about that, feel free to put in chat as well.
And to just build on top of that, if you are comfortable building on top of something that's on the more researchy side that doesn't have the enterprise support, how should you think about the differences between kernel memory and kind of what's provided inside of semantic kernel? So if we're looking at my screen, this is the kernel memory project, if folks aren't aware. It's all about, you can kind of tell from this diagram, it's all about taking documents and ingesting them. So it's a very opinionated way of having an offline process to extract information, chunk it up, save it inside of a vector DB so that later you can ask questions on it and get answers, right? And so if you're building a RAG application and this kind of satisfies all your requirements, this is something that you might want to use, right? What we are providing in Semantic Kernel and what's brand new are our new vector store connectors that are kind of replacing semantic memory, is more of the lower level abstractions that allow you to describe, hey, what am I storing inside of the vector DB? How do I save information? Let's see, your data model, defining sort schema, and record definition. It's more of those underlying concepts. And so if you have something that doesn't fit neatly into kernel memory, what you would want to do is use something like our base level abstractions within semantic kernel to create collections, upsert, and eventually search on these connections. And the plan is kernel memory will actually use these abstractions behind the scenes. And so it's not one or the other. It's either the core abstractions or both of them within something like kernel memory. Cool. But as Sophia mentioned, semantic kernel is a thing supported by Microsoft. You can jump on a call. You can yell at us if something's wrong. Kernel memory is something that's on the more researchy side. So yeah, we definitely want to have kind of a little bit of caution if you want to take a dependency on it. But it is very popular. We have seen a lot of customers use it quite successfully when necessary.
Perfect. But yeah, play around with both, like Matthew's saying, right? Have fun, experiment, right? That's really a key piece of test out and try some of these things. And so I see we have a couple more questions that I'd love to go through, and then we'll just wrap up and be able to leave some time at the end for Q&A as well. Eric has a question. Any pointers on to test your AI apps or services since AI is non-deterministic? It's a great one, Matthew. I'll pass it over to you.
Yeah. So that's all about excuse me, evaluations. So these are ways of basically using LLMs to score the responses of LLMs. So one of the most common ones used in Microsoft is we have a concept of groundedness. Hey, if you are building a retrieval augmented application, you retrieve a bunch of data and the AI is just like, I ignore this. We actually saw this, right? We saw when I provided those recipe chunks, the first time I wrote that prompt, it was like, I'm going to ignore this. Who needs this? And so the groundedness score for that example would probably be 0, right? It didn't use any of the information that we provided. Now, there is no code. Maybe there's some code I could write that could calculate that score. And so for me to do this at scale, I would actually ask another LLM to say, hey, here are the chunks. Here's the response. How grounded it is. Did it actually use some of this information? Score it from a scale of 0 to 10, and it would give it a score of 0. And that, to me as a developer, is a signal. Yes, none of this is deterministic, but it's a signal that something's going wrong, right? I can build integration tests that run this evaluation and say, hey, do not check in this prompt if the groundedness score is less than 80%, right? And so if I try to check in that prompt and I ran that evaluation, it's going to come back with a score of 0, and I'm going to get a big X saying, no, you cannot check in, you failed the test, right? And so I highly encourage customers. In fact, I know Sophia is working on a sample with the eShop example, where they're actually showing how to build tests using evaluations so that you can make sure that you're not checking in bad prompts. Great question.
Yeah, really great question. There's another really good comment in chat of an individual who's been using AI. They love to copy and paste terms of services and get a brief summary of unfair terms for a client of service. It's a great way to be able to see in the real world, right, how individuals are using AI and being able to pull it in. So really appreciate you sharing. What I can do is, so the next exercise and the next unit within prompt is really you just building and taking upon the work that we've been sharing and really building out for your own. But I'd love to do, if we have some more questions, is dive into them with the remainder of the time and anything that you may be going through any questions around different AI models and be able to go through and dive into that. So I see a question that's coming in chat from Ron. Are there special inferences for conversational or cached cases?
Yes, I think. Let's see. We have so many samples. Semantic caching. Let's see. Aha! Found it. Okay, so if we take a look at our screen, this is just going to be a quick plug for the many samples that we have within Semantic Kernel. So if you go into our repo, you go into .net, we have a samples folder, and we have a folder called concepts that basically show you how to do a bunch of different things. There was a ton of questions about RAG, how to use RAG. We just got a question about caching. There's a whole folder on caching. And so one of the things that we've been kind of talking about, alluding to, are filters or hooks. Let's see where. Let's see. Okay, so when you create your kernel, execute a sync, right line. It's been a while since I've looked at this sample. Get kernel with cache. Here we go. When we create this kernel, we're of course adding our services, but we're also adding these filters. So we have a filter here called iPrompt render filter. This is called before and after every time a prompt is rendered, every time we slot fill those different parameters. And we also have another filter for whenever a function is invocated, right? And we have these two filters that help support the caching scenarios. And so if we take a look at what those filters look like, whenever a prompt is rendered, after the prompt is rendered, we actually check to see if there is a response saved in a vector DB that is similar enough to the original question. And if it does, if we have a cached result, we'll just go ahead and return it. When we return it, we're done. We don't actually make a call to the AI. In this case, we're overriding the result, preventing the call to the LLM and returning the results immediately. Okay. The other thing that we need to do is, besides just returning the cache results, is that we actually have to save and cache answers as they come in. And so we can also see in this other filter that once a function is being done invocated, once a prompt is being done, we can grab the results of that prompt and we can save it inside of that semantic memory. So we can see here that we are caching the answer into this semantic text memory with this particular information. So definitely check out this example. Check out the other examples if you have particular questions of how to do something inside of Semantic Kernel. Cool.
Great. I see another question that came in. Is there a pattern for intent detection that we should use prior to calling plugins, or is that just a use case to use the stepwise planner?
So I see a lot of people trying to build intent detection systems, and this used to be necessary in the early days of AI because, again, the AIs weren't that smart. That is increasingly not necessary anymore. With function calling, let me go ahead and yep. Okay, cool. So if we come back to my screen, this is kind of the demo I always like to show folks. Hey, I'm giving the AI this light plugin, and it's just two functions: get the state of the light and change the state of the light with these two different functions. I give it to the AI with our standard add from light plugin. Oops, sorry, y'all. And we can have our back and forth chat with the AI application. You'll notice nowhere in here am I asking or having an LLM call that determines the intent of the user. All I'm doing is providing these available plugins and telling the AI this is what they can do, right? And so when I start my application and I start talking to my agent, I can say something like, please toggle the light. And because these LLMs are so capable, it is smart enough to make a call to get the current state of the light. It learns that the light is off, and then it can call another function, change the state, to actually turn it back on, right? In the olden days, you did have to have a separate step to detect intent. Once you've done that step, you have to choose which function to call. After that, you have to slot fill it, but none of that is necessary anymore with the power of function calling. In fact, if you try to break that into different pieces, we've seen in our own personal experience that it frankly gets in the way of the AI, and it performs worse. If we no longer share my screen, you mentioned the stepwise planner. That is actually one of the cases where we tried to kind of detect intent. We actually had the AI come up with a list of steps and then performed function calling. After having customers use it, us test it internally, we've actually found that it doesn't perform as well. It actually performs worse than just vanilla function calling. And so I know myself, Sophia, have had some blog posts that are actually, we're talking about deprecating the stepwise planner in favor of just function calling. So again, I just want to reiterate, if you are at some point in your AI journey and you're building an intent prompt, chances are you might be doing something wrong. You might be better served with just function calling. Okay.
Great. Thanks, Matthew. There's another good question coming from Eric. How do you see semantic kernel being used in the near future in apps for patterns of MOEs?
MOEs. Okay. I'm always learning some new acronyms. So
I was thinking the same. I was trying to look up what MOEs is. If you don't mind, Eric, just putting in chat for us, and everyone would love to know what the acronym stands for.
In the meantime, Brett saying that's cool, really cool. Catching up for the most current practices. Yes, I like to tell folks, if you're not using function calling, you're not using the best parts of the model. It is the way that OpenAI is having ChatGPT search Bing, use code interpreter, retrieve files. Like, that's what they're training their models to do. And it's going to just keep getting better and better and better. If you're not using that and you're doing something else to like choose the functions, if you have a big prompt that says, hey, detect intent and choose a function, you're not leveraging the millions, tens of millions of dollars that OpenAI is using to train function calling. And you can also see the rest of the industry. Google has function calling. Amazon has function calling. One day, hopefully, Llama has function calling. Everyone is kind of moving towards this route. And so that's kind of the de facto way of having these AI start performing automation. And it looks like, oh, go ahead, Sophia.
Oh, yeah. I was just going to say, it looks like Eric gave the acronym, so mixture of expert multi-agents. So just repeating the question, how do you see semantic kernel being used in the near future in apps where patterns of mixture of expert multi-agents are present?
Yeah, Sophia actually did a good job when she was walking through those slides. As she is writing something like a blog, yeah, you can have one agent that tries to do everything, but it kind of fails, right? And so having these experts defined, built with semantic kernel, and then kind of composed together is the excuse me, is the way you can kind of support MOEs. Again, I'm always learning new acronyms. This is great. The way we recommending architecting that in semantic kernel is each one of those agents is basically going to get their own kernel. And that way you can provide it with its own set of plugins, its own persona, and then you can kind of stitch these things together. One of the things that we are targeting for Microsoft Ignite is our multi-agent framework. We just released the preview version of it. So let me see if I can pull this up real quick. So if we share my screen again, we just recently blogged. I think we had the link to our dev blog where we talk about multi-agent support with semantic kernel, right? We walk through how do you build a single agent with OpenAI assistants. I think there was a question earlier that we didn't get to. When should you use OpenAI assistants versus semantic kernel? The answer is you use both. Even if you use OpenAI assistants with the raw SDK, your head might explode with the complexity of the APIs. With semantic kernel, we make it much, much easier to use. You're just basically writing this chunk of code. You can, of course, also just use what we call a chat completion agent that uses kind of the out-of-the-box pieces of semantic kernel. And then for these more expert scenarios, what we are introducing first is kind of those autogen patterns where you can have a group chat with a bunch of agents that kind of talk back and forth and work together. And we can go ahead and just stop sharing my screen. The other pattern that we're working on introducing by Ignite is more of a business process, right? So if you have a 10-step process, maybe there's like loops and cycles inside of it, providing an easy way within semantic kernel for you to wire these agents together to complete individual steps based on the expertise of those agents.
Great. And to close out, we'll go and end with our last question that I'm seeing from Ron, if we want to dive into that and close out with that last question. So some newer LLMs support input caching where you don't have to resend the previous conversation. How does the API handle
that? Great question. So most of the services that are starting to do some of this stuff, excuse me, are using something more along the assistance API, where they manage the chat history on the server. And all you're doing as the AI developer is adding new messages to it. So I'd recommend checking out the article that I just shared that shows how to use semantic kernel with the assistance API. And it will do some of that caching for you.
Great. Well, thank you so much, everyone, for all of your questions, for diving into the content. We have a bunch of the links that have been shared out as well to be able to learn more on semantic kernel docs, be able to clone the GitHub repo and go through all the samples that Matthew was showing, and then blogs as well that really highlight a lot of the great work we're doing. If you want to engage further, there are some links that have been posted on chat as well. But just want to thank everyone for joining in and for all your questions, and we look forward to seeing what you create. Thanks, everyone.
Thanks, everyone. Cheers.